everyone. So we're back again to do the critiques for the code challenge submissions for week number 2. So today I have with me here Ronald. Hello, Ronald.
Hello.
So, all right, so let's jump right into it. So in this week's challenge, we had 3 bugs that you were supposed to fix. So we'll go through each one of these one at a time. So this is the create a new card. Now the bug here is that the second parameter is incorrect. So Ronald, what's wrong with this, with the existing implementation?
In the existing implementation, it just trivially returns the first suit in the card array. So what we need to do is actually figure out what the suit of the card, each card is, and return it.
Yeah. So then.
So because we're getting the suit as a parameter already, actually, it's a pretty trivial solution once you realize that. So you just need to change the card.get suit.value into suit.
Okay, awesome. Yeah. So I think most students got this bug all right. So great. And then let's look at the second one. So this one, we're supposed to draw a card and remove it from the top of the deck. So the problem here is this. So again, Ronald, what's the problem with this one?
So this one, we're getting the card from the deck, but we keep getting the same card and we don't remove it. So the solution is actually to get the card and remove it. And there's quite a number of different ways you guys have done it. So we're going to go through a couple of them.
All right. So there's this first one here that most students actually implemented this. So can you walk us through what this does?
So the solution that most students have given us is to keep the get call, set it to a variable, remove the card, and then return the variable you set.
Okay, great. Yeah, that makes a lot of sense. Very logical and very straightforward, right?
Yep.
Now there's another variation that we saw, and one student implemented this, and walk us through this. What's the difference between this and the previous one?
So this one actually, it's a one-line solution, and the difference is that it actually combines all 3 of those previous lines. So you get the card, you set it to a variable, you remove it, and then you return it. This does it all in one go. And that's because the call to remove also returns the card that you remove. So the need to set the extra variable is actually unnecessary. So this one is probably the most simplest solution in terms of doing what the objective of getting the card and removing it. And that's just a little bit more straightforward and a little bit less error prone in case, between the first and second line, someone set the deck.remove to 1 instead of 0, for example.
Yeah, that's right. Yeah, so I mean, this one makes a lot of sense, but yeah, like you said, it's a contrived example, but potentially someone could put remove 1 in the second line while get 0 in the first line, and that would be a bug, right? Well, as you said, in this one-liner, there's no way to make that error because there's only one place where we have the index as 0. So a big shout out to JE. JE was the only person who returned this. I prefer this also because it's just cleaner, but it does, like you said, require prior knowledge that dot remove actually returns the element also, which is not that obvious when you look at the name of the function, right? Okay, so then the third function that they needed to fix was this one: get the value of the Blackjack card. So this is the existing implementation, and again, there's a problem here. So what's the problem here, Ronald?
So in the provided solution, the problem is that when we get the index of, this naively returns the same number that the index of the value of the card is at. So for the higher number cards, Jack, Queen, King, because their index, well, that would be 10, 11, 12.
Yeah.
I believe. No.
11, 12, 13. No.
I do.
Yeah. 10, 11, 12.
10, 11, 12. Yes.
10, 11, 12.
Yeah. So for the higher suites, Jack, Queen, King, because it's index 10, 11, 12, it will simply return that number. So in Blackjack, because Jack, Queen, King are all the same values, which is 10, when you simply return the index, you're going to get the wrong values for those higher suites.
Okay, awesome.
Because the index of does not take into account of the zero, the array starts at 0, whereas the value is 1. So you're going to also have an off by 1 error on this one.
Yeah, that's right. That's a good point. Okay, so let's take a look at some of the solutions. So this solution, most of the students that got the correct answer had some sort of variation of this one. So can you walk us through what this does?
So in this example, basically it resolves the two problems that I kind of talked about, whereas where the higher number cards, Jack, Queen, King, we set them to the value of 10. And you also handle the off by 1 error in the second else clause. But this one, you can see that it's about 8 to 10 lines or so of code. So it's not the most concise. So we just wanted to introduce a couple of variations to get you to think about the trade-offs from a kind of first pass solution into something a little bit more optimized.
Okay, great. Yeah, so like what you're saying, this is one variation. What's the difference between this variation and the previous one?
So in this iteration, we dispense the use of an additional variable called value, and we can just directly return the calculated value of the card. So here in the if and else, we just directly return either 10 or return the index plus 1. We don't need to set the variable first and then at the bottom of after the if else clause, if else conditions to return the value.
Yeah.
So this
definitely.
one is a little. Oh, sorry.
Oh, go ahead. Yeah.
So this one is a little bit more, I guess, a little bit more concise and also less prone to errors because you're not going to accidentally forget to set a variable or you forget to update the variable and then return the wrong thing. This is very clear on what it's going to be returning.
Yeah, definitely looks cleaner. But we can take it one step further, right?
Yes.
So walk us through this one.
So this one, we dispense the if-else loops into something called a ternary. So a ternary, if you have never seen this before, works quite similar to an if-else loop. So we forget the return for now, and we just look at starting where it says index is greater than 9. So that is kind of like the if condition in the if-else loop. So if the index is greater than 9, the question mark is kind of like the opening curly braces in the conditional. And then you can see the colon. So to the left of the colon, that's if the index is greater than 9 and it's true, then we do 10 and we return. And if the index is not greater than 9, then we do the second to the right of the colon.
Yeah, great. So it's basically logically equivalent to this. It's just a shorthand way of doing it. And just a quick shout out, we do have a video on ternary operators in our tips and tricks videos. So if you're interested to watch that video, we'll put the link in our description, or you can maybe click somewhere up here and we will put a link to that. But yeah, awesome. So I guess for someone who's not used to looking, who's just beginning to learn ternary operators, this looks a bit cryptic, but it is used in a lot of programs. A lot of developers do write this just because this is so common, right? This pattern that we see here is so common, where you're returning a value based on one if condition, and it's either one set of values or another set of values. And so whenever you see that, as long as there's no other logic inside the if and the else clauses, then that's a candidate for refactoring to a ternary operator. Mm-hmm. Okay, awesome.
I think what's important is that you know when to use the ternary and not, and when to identify when someone uses it, and how to read the logic, because it might not be as common as if and else, but it does come up every now and then. So yeah, it's good to have it in your tool belt. If you're not familiar with it, definitely check out the video.
Okay, awesome. Now, so this could be even taken one step further. So walk us through this one.
So this one, we dispense entirely of the index, and we just directly calculate the index of the number in each of the places where in the variation number 2 example, we set it to an index. So if we go back one slide.
Yes.
So you can see that, we in this example, in variation number 2, we set the index to be numbers.index of. So if we go back to variation 3, we just simply replace the places where we use index, the variable index, with the calculation directly. And you can see that logically this is equivalent, but it could look a little bit cryptic, and it's a little bit hard. It's starting to be a little bit hard to understand. So we wanted to include this example just so you can see the extent of how optimized you can make your code into basically one line, and it does all the logic that a lot of you did in 8 or 9 lines. But there is kind of a balance of, where you want to optimize to, because for this solution, this is pretty hard to read, and without the context, you might not be able to pick up what it's doing right away. Whereas for variation 2, for the most part, it's pretty easy to understand as long as you understand what the ternary is doing.
Yeah. Yeah. So you would prefer this variation over variation 3?
I would probably stick to no less than variation 2. And there's nothing wrong with variation 1 or even the solution that the majority of students submitted. But for the optimization, I would probably say variation number 2 would be about where you should end up.
So I think one of the reasons why we showed you these variations is because we wanted to show you that there's this whole process of kind of coming up with the variations is called refactoring. So we refactored out initially the variable called value, and then we refactored the if-else into a ternary operator, and then this last one is refactoring the index variable out completely. But this shows that you could actually refactor a little bit too much. And so part of being a good developer is kind of understanding where that balance is, and where it makes sense to refactor, and where an additional refactor might be a little bit too much, and we are sacrificing readability. The good thing about this variation 2 is that it's very readable, very understandable. Variation 3 is harder to read, and it takes a little bit more mental cycles to understand, right? Mm-hmm. So it's not wrong, it's just less readable.
Yeah. And I guess if taking this back into your projects, I think the key is that it's okay to start with a naive solution where, it's not optimized, it does the job, but refactoring should be kind of on the back of your minds, because the moment you say, oh, I'm going to get back to this, or, I will deal with this towards the end, well, most of the time, when the end comes, or you say you're going to do this in the future, most likely there won't be a time or the opportunity doesn't present itself anymore. So definitely nothing wrong to start with the naive solution first, but just keep in mind of, when you are developing your app, if you see the opportunity to refactor and there's time to do it, it's better to do it now instead of later.
Yeah, awesome. Yeah, we call that technical debt, right? Okay, let's move on to the next one. So there's another variation that I wanted to show, and actually a few people did something similar to this. Now, Ronald, walk us through this. This is slightly different, right?
Yeah, so in the previous solutions that we showed, all of the variations took in the index number of the cards. So because the array we provided you goes from 1, 2, 3, 4, 5, it's a sorted array. That solution is good and it works, but it is a very hard dependency and a big risk if, for example, the array gets unsorted, or maybe the array data structure or whatever gets changed such that it's no longer sorted. So in this solution, we don't depend on the sortedness of the array. We actually look at if the value equals Jack, Queen, or King, then we directly set it to 10. We directly return 10. Otherwise, we figure out what the number actually is, and then we can return it.
Yeah, I'm not sure if there were 3 students. Shout out to those 3 students. That was William, Ali, and Jay who provided this solution. I'm not sure if they had this in mind, but actually I thought that was really elegant in that there's no dependency at all on how the array is ordered, and it actually looks into the value of these elements to determine what value should be returned. So that's really awesome that they did that. The performance of this algorithm or of this function here is definitely less performant than the other solutions that we looked at. But I like it because it is more robust, because there's no dependency, like you said, on the ordering of the array. So it is a little bit more bulletproof code. So it's a lot more robust in that sense. Yeah. So those are all that's the critique that we have for this week. Thanks all for joining us. Good job to everyone who submitted. I really enjoyed looking at your solutions. So keep up the good work and get those streaks going. See you next time. Bye-bye.